There's another design principle we have, which is our scale. So we want our tools and our computations to scale, and scaling can work in different directions. You can scale up to very large scale problems, you know, millions of equations, millions of variables, you know, huge problems. But there's also scaling down to small scale, so small numbers, small problems. And both of those are, or in programming, scaling can be important.
I mean, scaling
as well.
is across the whole system.
Right.
Because in programming, I thought was a very obvious example. I mean, there are systems where, you know, to program some very large project, they may be a good thing, but it takes you an awfully long time to get started for a relatively simple task.
Absolutely, right.
So I think mathematics is pretty much unique in being able to go from sort of one line, really meaningful, meaty program
up to massive
programs.
That's right.
Tens of thousands or hundreds of thousands of lines.
So a good example of that is our user interface construction tools that we have. So often, one thing they do very nicely is scaling down to very small scale little user interfaces. And in Mathematica, you know, a one-line command can produce a non-trivial user interface. And that opens lots of options and possibilities to people who are not expert programmers and that just simply were not able to.
It's almost like this citizen programming thing where you...
Citizen programming, it's a good term, right.
Yeah,
right.
So where people who aren't really, you know, programmers in themselves, they wouldn't class themselves as either amateur or professional programmers, are making interfaces which other people can use.
Exactly. No, I think that's... Now, the more traditional approach to building a user interface might be to use, you know, a sort of a GUI builder. And such things can be useful, but for very small things, they're hopeless because you have to go through, you know, many steps, about sort of 10, 15 different steps. And it's there, you're applying a solution that scales very poorly to a small scale problem.